Okay, I think we'll get started. So today we're going to talk about a fun little application of titrations and an important one for doing analysis, and that is back titrations. So we've talked about titrations now for a bit, and one of the key features of a titration is that the reaction go fast and all the way to completion, so to completion fast, so that we have a very sharp endpoint, and that we have, or equivalence point, I guess, and that we have a indicator that will have an endpoint that matches the equivalence point pretty close. Now, it turns out that a lot of reactions are sluggish or aren't suitable for a titration. So say, well, okay, how can we do this, or are we just out of luck? Well, one technique is called the back titration, and what's done here is that, let's say we have some unknown sample that contains a certain amount of material, but we don't know how much. So maybe a piece of brass and it has a certain amount of copper, or as we're going to do in this example, we're going to have some copper hydroxide, say, mixed in a sample of, whatever, it's a little bit of sand and salt and whatever. And so we're not able to take this to the balance, measure out the mass as if it were pure sample, and then just do a grams to moles conversion, or just a percent, weight percent, if that's all we wanted. So we don't have that, so we have to do some kind of reaction, but this reaction is going to be slow. And so what we're going to do is we're going to take a standard, and then we're going to dump that standard onto our sample, and we're going to make sure that we have that the standard is in excess and the unknown is limiting. So we may have to do some pre-calculations. We won't do that in the example here, just to know that we're going to make sure that this is going to be excess. So in the most gross sense, what you could do is just assume the entire sample is the analyte that we're interested in, and then just make sure you dump in enough standard so that you're in excess. If you know a little bit more about the standard, so if you know it's only about 1% or something like that, then you can make adjustments accordingly. So there is some pre-work that might need to be done, but we're going to focus here on just the act of the back titration. So we're assuming we can put a standard in here, and maybe this takes a long time to react. So maybe it takes a day or two to react, but that's okay. We can let it react as long as we want. Now, the idea is that we'll have some excess of our standard. We won't have any idea what that is, how many moles that is, but we do know that we can titrate that with a titrant. So the standard is something that does get involved in a nice titration reaction. And so we can titrate that with a standard titrant and figure out the remaining standard. Well, if we know the remaining standard, we know the standard we made up, then we can figure out the amount of standard that actually reacted with the unknown sample. So that's the idea behind the back titration. So just to summarize then, we react the unknown with a known standard, and the unknown is the limiting reagent. We titrate the excess of the standard with a standard titrant, and then from that we can determine the amount of reacted standard, and then we can determine the amount of unknown. So that's the procedure that we'll go through. Okay, let's bring this to life with a real example. And so we're going to take a sample of a 1.2 gram sample of whatever, let's say a mixture of sand, salt, and copper hydroxide. And we're going to try to figure out how much copper hydroxide is in this sample. So in a weight percent. So do we have, is it 50%? Is it 40%? Whatever. Okay, so we're going to start now with adding 50 mils of 0.1 molar HCl. So this is acting as our standard. So here's our standard right here, because we know precisely the concentration and we know how much we added. Now the reaction that will take place is the reaction of the HCl with this solid copper hydroxide sample, and that'll produce copper chloride and water. And this reaction will go pretty much all the way. Now, what we're going to do is we're going to say this remaining solution is titrated with 1 molar or 0.1 molar sodium hydroxide. So that's the titrant over here. So this is the titrant. And we reach the end point at 20 mils. Okay, so that's what happened in this example, we'll say. Well, what's the titration reaction? One we've used a lot, sodium hydroxide and HCl, sodium chloride and water, 1-to-1 stoichiometry. So let's go ahead and calculate the things we need. So we're going to need the total moles of the standard. So this is in the standard. And so 50 milliliters times 0.1 mole per liter is 5 times 10 to the minus 3 moles of HCl total in the standard. Okay. So that's what we put on top of, so here's our copper hydroxide sample. This is our HCl sample, and this is how many moles we've dumped into this beaker here now. Okay, so now let's calculate let's determine the excess of the standard here. So it took 20 mils, right, or 0.12 liters of sodium hydroxide, and we're going to multiply that by 0.1 mole per liter to give us moles of sodium hydroxide. So that's coming from the concentration of the titrant. Then let's do moles to moles. Because of this reaction, 1 mole to 1 mole, and that'll give us moles of HCl. This is a place where it's easy to make mistakes. You want to make sure that you follow your units and get all the way to moles of what you're interested in, which is the standard, moles of HCl. Lots of times the reactions are 1-to-1 and you can get away with that mistake, but important to be cognizant of it and try to get all the way. Now do this moles conversion even though it's 1-to-1. All right, so now we have the number of moles that are in the excess sample here. So we've dumped this in here, we've let this reaction go, we're now titrating this, and we've determined the number of moles in here. So that's how many moles were left over that did not react with the unknown. So we need to figure out how many did react with the unknown. So what reacted with the unknown? Well, we take our total moles, which is this, minus our moles of excess, and that gives us moles of reacted HCl. Okay. Now, when we say reacted here, we're talking about reacted with the original unknown. At the end of it all, it's all reacted. Unknown, and then the excess is reacted with the titrant. But what we're going after here is how much has reacted with the unknown. All right, well then this becomes a problem we've been doing all along, and that is we've got moles of HCl, and we need to convert that to moles of what we're interested in here, which is the copper hydroxide. Our stoichiometry is 1-to-2, so 2 moles of HCl produce 1 mole of copper hydroxide. Then we do this calculation, and we get 1.5 times 10 to the minus 3 moles of copper hydroxide in the unknown. Now, we want a weight, so basically we're done here, but we want a weight percent. So let's convert this number of moles to mass. So the molar mass of copper hydroxide, if you work that out or look it up, is 97.56, and then we get a amount of grams, which is 0.146. Take that, divide by our original sample of 1.2, and multiply by 100%, and we get 12%. So we have a 12% weight, so I should probably put weight percent to indicate that it's mass of unknown over total mass of the sample. All right, so that's a back titration. And again, these are very valuable in situations where we do not have, where the reaction of interest does not have the characteristics that are good for a titration setup. And so this is something that you want to be familiar with, very important technique, and it pushes us to understand the titration a little bit better and understand where all these moles are coming and going from. All right, so I'll have a few problems in the attached notes. There won't be any, I don't think there'll be any problems in any chemistry book that general chemistry book that you would have. These problems you can usually find a lot of these problems in an analytical chemistry book if you're looking for more, or just Google problems on back titrations, or have ChatGPT make some problems on back titrations to get some extra practice here.